Hi folks, in this video I'm going to tell you a multi-criteria decision-making example with regards to inventory classification. This is a more efficient and cost-effective way of inventory planning compared with single criterion. So whether you are a student or working in the industry, you will find this video very helpful. So if you are a student, this video can improve your knowledge in inventory planning so that during the interview process, you can present this example to say how you will approach improving inventory planning if you get the job. On the other hand, if you work in the industry, in supply chain area, or you are a data analytics professional, this can be a good continuous improvement project for you. Before I explain multi-criteria inventory classification, let's have a quick look. How do we classify inventory using single criterion, and how do we use it for safety stock level settings? So we can have a comparative evaluation when I present multi-criteria technique. So let's get started. So single criterion is based on single criterion, as the name suggests, and most of the time it is annual consumption or annual usage. So inventory items are classified into A, B, or C based on Pareto rule, which is also called 80-20 rule, which suggests 20% of items are responsible for almost 80% of total consumption. And based on that, we set a cutoff points of A, B, and C, based on Pareto rule. Okay. The thing is, since this only considers single criteria or one criteria, stockouts or excess inventory situation may still occur because it does not consider other factors which can be relevant in inventory classification. For example, lead time. Now let's take a look one example on single criterion ABC classification before we move on to multi-criteria. You are seeing this table in your screen. This contains 47 items that we're going to go and classify using ABC classification. Okay, you see that 47 items here. So these items have been used in the literature in the past. I have provided the details in the description if you're interested. So we have the information already available on the average unit cost and annual consumption. And also, if you are working in the industry, you know the average unit cost of each item and the consumption for last year or this year or any year, you can access from your system. And you will be dealing with thousands and thousands of items, but the method is same, right? If you understand the method I'm going to tell you using the 47 items, you can apply to any number of items. So once you have these two information available, you can calculate the annual consumption value using the unit cost times annual consumption. So you can do it for all the items, all the 47 items. Then you can calculate the percentage of total consumption for each item. Okay, this means that how much item 1 is contributing to total consumption of all items. This tells that item 1 is contributing to 11.3% of total consumption, including all 47 items, right? So same for item 2. Item 2 contributes 11% of the total consumption. Item 3 contributes to 9.7% of total consumption, right? And in this column, I calculated the cumulative percentage of total consumption, okay, so that it can help me classify the inventory items. So the data is ready to classify the items into A, B, or C. The very first thing we need is the cutoff points. So we set 0 through 70% class A, 70 to 95% we're gonna use for class B, and 95 and above we'll use for class C. Okay, so this is in line with Pareto. Okay, that tells 20% of item contributes to 80%. we're gonna take a look once we classify how many items fall under class A. Okay, so since we set a cutoff point of 70% for class A, we're gonna take a look where do we end at 70% consumption. Okay, here, see that. So from here to here, the consumption is less than 70% or until 70%. So we're going to classify all those items under A, and 70 through in 90% we're going to classify under B. So let's take a look. Yeah, sorry, 70 to 95% under B. So that's here, and 95 and above we're going to classify uh, under C. Okay, that's what we did for all the items. Okay, 47 items. Okay, so if we take a look, we see that number of items in class A, we said 9 items. Okay, so we see 9 items in class A, 18 in B, and 20 in C, so total 47 items. Now we're gonna see how much percentage of items in class A. Okay, let me unhide it. So this tells that almost 20% of total items fall under A, 38% under B, and remaining under C. Okay, so this is in line with Pareto, which says that 20% of the items contribute to almost 80% of consumption. Now we can use this information to set safety stock levels on class A, B, and C. As you see that class A items are those items which have higher consumption compared with B and C. Okay, so meaning that they have higher demand than B and C. So since they have higher consumption, okay, consumption value, so they will be contributing to higher revenue as well. Okay, so in the future they have higher demand because historically they have been selling good. So in the future as well, we assume that they will be selling good as well compared with B and C if the trend continues. So we're gonna make sure we don't face any stock outs on class A items. So we're gonna make sure we put higher number of safety stocks weeks on class A than B and C. Okay, I repeat, we're gonna make sure that we're gonna put higher number of weeks of safety stock on class A than B and C. So I'm putting 5 on A, 3 on B, and only 1 on C because class C are those that are not contributing much towards consumption. Okay, so these numbers are just an arbitrary number. It depends on which industry you are working. Okay, so depending on the industry and the total lead time of all the items, you can figure out what could be a good appropriate safety stock for class A, class B, or class C, or you can use safety stock formula. The point I'm trying to make here is we're going to make sure we put higher safety stock number of weeks on A than B and C. Now we have put the safety stock, we can calculate the inventory cost on each item. So 5 weeks of safety stock will incur around $560 item on class A. Okay, so how do we calculate inventory stock? Sorry, how do we calculate inventory cost due to safety stock? So we have annual consumption. You're gonna convert into the daily consumption, then convert into the weekly, multiply by 7, and then multiply by number of weeks of safety stock, and then multiply by unit cost, average unit cost. So that gives you the inventory cost on item 1. Same for item B, sorry, same for item 2, item 3, and so on. So altogether, if we sum for all 47 items, the total safety stock cost will be 4,231. So in this video, you saw how do we classify items into A, B, or C using single criterion, and how do we use that information in putting safety stock, and what will be our total safety stock cost if we put those values. Now we can convert this data into Pareto chart. As you see in your screen, you have noticed that class A was around 20% of the total item, class B was around 40%, and class C was around 42 to 43%. The cutoff point for class A was 0.2 and class B was 0.6, okay, and class C was 1. In terms of total consumption value, you also have noticed that class A contributed around 70% of the total consumption value, and class B contributed around 25%, and class C 5% only. Okay, so accordingly, I put the cutoff point for class A, B, and C. Okay, 70%, and from 70 to 95% is class B, and from 95 to 100% is class C. So this is how Pareto chart looks like for ABC inventory classification using single criterion. Now we can talk about multi-criteria inventory classification, and we will see how this inventory classification can improve the inventory planning. In multi-criteria, we use more than one criterion to classify the inventory. So besides annual consumption value, we can also use lead time as a second criterion to classify the inventory. The reason why I chose lead time most of the time, because to me, lead time is a very important factor to keep the inventory levels high or low. Okay, because you do not want to keep the inventory levels high on those items which have a shorter lead time or which you can get very quickly from your supplier. Okay, similarly, you can set another criterion based on your supply chain dynamics or based on how you're operating your supply chain. I think, for example, the third criterion could be based on supply shortages. Okay, so you want to keep the inventory levels high on those items which have a supply shortage history. So this could be another factor in classifying the inventory. Okay, so in this example, I am putting two factors or two criteria. One is annual consumption value and second is lead time. So from single criterion example, we know that we have 47 items and we have the annual consumption value we calculated using annual consumption and average unit cost, and we also put here lead time for all the 47 items. Okay, so the next step is converting the values of our criteria into 0 to 1 scale using normalization. Okay, so that's what I did for annual consumption. Okay, for all the items 1 through 47, I converted those values into 0 to 1 scale. Similarly, for lead time, I converted the lead time of all the 47 items into 0 to 1 scale. I normalized those values. So the next step is calculating the total score. In calculating the total score, we're going to apply the weights on the criterion based on the importance level. Okay, in this example, I'm considering both of my criterion as equally important. So I'm putting 50% weightage on each criterion. Okay, so in calculating total score, I'm applying 0.5 on annual consumption value, and also I'm applying 0.5 on lead time. Okay, so that gives me a total score for all the 47 items. Now the next step is converting those values into 0 to 1 scale, normalizing those values. Okay, so now we have the total score for all the 47 items. The next step is classifying those items into A, B, or C. Okay, in order to do that, we need to set the cutoff levels. So I'm going to use the same cutoff level that we used for single criterion. Okay, so we selected 9 items in A, 18 in B, and 20 in C. Okay, so that gives 20% in A, 38% in B, and 42% in class C. Okay, so let's see. So I'm gonna filter it based on the total score, high to low. Okay, so I'm gonna classify top scoring items into A, top 9, and then another 18 in B, top scoring, and then remaining items into C. Okay, so remaining items into C. Okay, now the next thing is we're gonna set the safety stock level. So I'm putting 5 weeks on class A, 3 on class B, and 1 on class C, similar to ones that I put in single criterion. Okay, so meaning that I'm putting the same safety stock levels into A, B, and C that we put in single criterion so that we can compare the results. Next step is calculating the inventory cost on each item based on the safety stock level we set. So same formula that we used in single criterion. Okay, so we convert it into the daily value, then convert into the weekly, and then multiply by the cost. Okay, and then the safety stock number of weeks, then we got the inventory cost on each item. Okay, so if we combine all of those values for 47 items, our total inventory cost is $3,587. And if you notice, this is lower than the one we got in single criterion. In the single criterion, our total cost was 4,231. So that's better, right? Okay, now we move to multi-criteria using unequal weights. Okay, the same thing, only thing changing here is the weights. Okay, so for me, annual consumption is more important than lead time. So I'm putting 60% on annual consumption and 40% on lead time. I'm putting 0.6 on annual consumption, okay, when I'm multiplying in the formula, and 0.4 on lead time. Okay, so now it gives me total score. I'm gonna convert into the 0 to 1 scale. That's what I did here. Now we have the total score on all 47 items. Okay, now we're gonna classify into A, B, and C. So I'm gonna unfilter. Okay, now so the top 9 items, okay, as we saw in the previous example, gonna put in class A, and remaining on class B, and remaining on, and then leftover into class C. Okay, so I'm gonna filter it based on the total score. Okay, so top 9 items I'm gonna put in A. That's what I did. Okay, so we classified top 9 items into A, remaining 18 items into B, that you see here, remaining 18 items into B, yeah, see, and then the leftover into C. Okay, good. So we have class A, class B, and class C. Now we're gonna put the safety stock level for each item. So I'm using 5 weeks on class A, 3 on class B, and 1 on class C, similar to the one that I used in the previous example, just to compare the results. Now I can calculate the inventory cost on each item. Okay, same process. Okay, when I take the total of all the 47 items, I get 3,976. Okay, which is little higher than the equal weights example. Okay, one thing I want to point it out here is how to apply weights, right? How do we know the weights? Here I'm using it manually, right? But there are different methods that we can use to find out weights. For example, analytic hierarchy process, or you can use linear programming, right? You can set a constraint based on the importance level, okay, and set the objective function so that it can minimize the total cost of the inventory. This way, it will give you the weights on each criteria for each item. I'm not going to go into that detail in this video because this will make my video very big. But in the future, I can make a video on how to calculate weights using AHP and linear programming methods. So as you saw in this multi-criteria, in the multi-criteria, we also considering other factors that are relevant in keeping the inventory levels low or high. Okay, in this example, our total inventory cost came lower than the single criteria. I put a summary here. In single criteria, we got $4,231 total inventory cost. Then we have for equal weights 3,587, and then we have for unequal weights 3,976. But these numbers could change depending on your inventory items and the cost. Okay, but the method I explained to you, you can use the same method in using multi-criteria classification for your item. We can also solve this multi-criteria example with linear programming as well, which will make this problem as a minimization problem where you want to minimize the total inventory cost based on the importance level you set on each criterion. Okay, we'll take a look in the future videos how we can do that, and we'll also try to do these examples in Python. So that will make your life very easy. If you like this video, please subscribe and share. Thank you so much.